Hello guys, welcome to our channel Shubhada Group of Education Sirsi. You are watching Satish's physics videos for CET and NEET. So here is a problem on magnetism and matter. The problem says that an iron rod of length L and magnetic moment capital M is bent in the form of semicircle. Now its magnetic moment will be. Okay, so while discussing the synopsis on the same chapter, suppose if this is what the north pole and this is the south pole, and they say that the length is L here, at that time the each has a pole strength M. After that we have defined the magnetic moment as the pole strength into the length of the magnet, that is what M into L, correct. Now the same magnet is bent in the form of semicircle, if you bend the magnet in the semicircle, its pole strength remains the same, so it will be the same M itself, but the length will become changed, that is what 2 times the radius, because this is what radius r and this is what the radius r. Now the length or the distance between the two poles must be equal to 2 times r, correct. As it is a semicircle, I can say that L dash must be equal to 2r, that must be equal to how much it is, 2 pi r divided by 2, because it's a semicircle, the circumference of the circle is 2 pi r. Now the same, as it is a semicircle, that's the reason it is divided by 2, that is what equal to pi into r. Is it correct? So this is what we have to remember while solving this problem. This is what very much important here. Okay, so by using this one, I can say that, as you know that the magnetic moment M equal to M into L, while it is in the first case, and it's in the first case. Now the new magnetic moment M dash must be equal to pole strength will be the same into what? Into, this is what, now I can say that R is equal to L by pi, right? This is what L dash, R equal to, you can say that R equal to L divided by pi now. L divided by pi now by using this one. Okay, L dash divided by pi. However, no problem for this one now. Okay, so now this is what L divided by pi. So therefore I can say that M into L is capital M, that is what M divided by, this is what M divided by pi into what, 2 into 2. So that's the reason why 2 times, this is as I said 2 times R it is, so that's the reason why it is 2 times M by pi, 2M by pi, 2M by pi. So option B is the right answer for this question. Okay, a magnet of magnetic moment M and pole strength M is divided into 2 equal parts. Then the magnetic moment of the each part will be clear. So here in this particular problem, we have two different options. Say this is a magnet now. I can cut this magnet like this, okay, horizontally, or else I can cut this magnet like this, okay. In this fashion I can cut this one. Okay, so here if it is the magnetic moment or the pole strength is M here, say this is M here, so the length is same. Okay, length is same, so this is what L here. So while cutting it horizontally, at that time the pole strength will be half of that, but here in this case pole strength will be the same, M will be the same, but the distance is reduced by what? L by 2 here. Okay, let me take this case now. First of all, the new magnetic moment equal to M by 2 into distance same, correct? So that's the reason why M into L is nothing but capital M, that is what the pole strength into the length divided by 2. So that's the reason why M by 2 is the right answer for this particular question. If you use this case also, you'll get the same answer here, because the magnetic moment, the new magnetic moment M dash must be equal to pole strength into the distance, that is what L by 2. M by 2. M into L is capital M, that is what M by 2. So this is my same answer. Option B is the right answer for this question. Okay. Next problem. So the next problem is a bar magnet of length 10 centimeter and having the pole strength equal to 10 to the power of, how much it is, 10 to the power of minus 3 Weber. Let me take this, 10 to the power of, it's not visible, right, currently. This is 10 to the power of minus 3 Weber is kept in a magnetic field having the magnetic induction equal to 4 pi into 10 to the power of minus 3 Tesla. Okay, if it makes an angle of 30 degree with the direction of the magnetic induction, the value of the torque acting on the magnet. Okay, so how to find out the torque here? You know that torque tau is equal to m into b into sine theta, correct? So m is nothing but pole strength into the distance or the length of the magnet into b into sine theta here. Clear? So the pole strength is how much now? It is pole strength is equal to 10 to the power of minus 3, and the length of the magnet is how much it is? The length of the magnet is 10 centimeter, 10 into 10 to the power of minus 2 meter, and the magnetic field is given by 4 pi into 10 to the power of minus 3 Tesla. The sine, the angle is how much? 30 degrees. Sine 30 is nothing but 1 by 2. 1 by 2 now. So left with what? 2 pi, 2 ones are 2 twos are here, 2 pi into 10 to the power of minus 7, right? Minus 7, exactly, it is minus 7. Minus 7 to 2 pi into the power of minus pi Newton meter. So this is why option A is the right answer for this question. Okay, the next problem says that a magnetic needle lying parallel to the magnetic field requires W units of work to turn it through 60 degree. The torque required to maintain the needle in this position will be. Okay, so we need to calculate the value of the torque. Torque tau equal to m into b into sine theta in terms of the work done. So how do you find out the work done here? Work done is equal to m into b into what? Cos theta 1 minus cos theta 2. Initially the magnetic needle is lying parallel to the magnetic field, correct? So that's the reason why we can take cos theta 1 equal to 0 degree. That's the reason why m into b into cos 0 degree. Cos theta is 60 degree, cos 60 degree. Clear? So therefore I will get m into b into 1 minus 1 by 2, that is what? 1 by 2, that is what? mb divided by 2, mb divided by 2 here. Okay, so therefore I can say mb must be equal to 2 times work done. Okay, 2 times work done. So therefore I can say torque tau equal to, instead of mb I can substitute 2 times w into sine of 60 degree. 60 is nothing but root 3 by 2, right? Root 3 by 2. 2 times w into root 3 divided by 2. Now 2 gone, we left with root 3 times w. Okay, so that's the reason why option A is the right answer for this question. Go to the next problem. Two equal bar magnets are kept as shown in the figure. The direction of the resultant magnetic field indicated by the arrow head at the point P will be. So now here is the point P, right? Here is the point P now. As this point P is nothing but perpendicular bisector to this magnet, correct? So that's the reason why, as you know that the magnetic dipole moment is from south pole to north pole. South pole to north pole here. This is what the magnetic dipole moment. But in the perpendicular bisector case, the resultant direction of the magnetic field is opposite to that. So that's the reason this is what B. Let me take it as B1 here. Okay. And as it is an axial case, this point P is along the axis to the second bar magnet. This is the first bar magnet, second bar magnet. So as the magnetic moment is from south pole to north pole, and the resultant magnetic field due to it will be in this direction. Okay, so the one is along this one. This is what B2 now. B2 now. Okay, both are 90 degree to one another or perpendicular to one another. This is the reason why this is what the resultant. This is what the resultant magnetic field. So this is why option B holds good. Option B is the right answer for this question. Highly conceptual question, very good question. The seventh one, two like magnetic poles of strength 10 and 40 SI units are separated by a distance of 30 centimeter. The intensity of the magnetic field is 0 on the line joining them. Okay, so let's try to solve this problem. As you know that, as we studied in the first chapter, so magnetic field B equal to mu naught divided by 4 pi into 2m divided by r square. Please try to remember this one. Okay, 2m divided by r square. Okay, so by using this one, or else let me take the naught axis. This is just m by r square. Try to remember that like this. So say this is what 10 units and it is what 40 units now. Okay, so for example, This is the point P at which the resultant magnetic field is going to be 0, which is at a distance of x here. And here to here it is what? The length is how much it is? 30 centimeter. Okay, 30 centimeter. So this distance must be what? 30 minus x centimeter, correct? So that's the reason why. If both the magnetic fields are opposite, then the resultant magnetic field at point P is going to be 0. So therefore, let me take here mu naught divided by 4 pi, the magnetic 10 units divided by r square, that is what, x square, that must be equal to mu naught divided by 4 pi into it is 40 units divided by 30 minus x square. Okay, so now 10u, it is 4 times. Okay, 4 mu naught by 4 gone, it is 1 divided by x square equal to 4 divided by 30 minus x square. Let me take the square root on both sides. 1 divided by x equal to 2 divided by 30 minus x. It implies 30 minus x equal to 2x, x equal to 10 centimeter. If x equal to 10 centimeter, this 30 minus x must be equal to 20 centimeter. So that's the reason why 20 centimeter from the stronger pole is the right answer, option B. Next problem, a magnet of magnetic moment 50 I cap ampere meter square is placed along the x-axis in a magnetic field 0.5 I cap plus 3.0 J cap Tesla. The torque acting on the magnet will be the torque 2 equal to m into b into sine theta, or else it is m cross b. Okay, so suppose if it is m cross b, at that time the magnetic moment is 50 times I cap cross 0.5 I cap plus 3.0 J cap. So now I cap is going to be 0. I cap cross J cap is K cap. That's the reason why 150 K cap Newton meter. 150 K cap Newton meter. Option B is the right answer for this question. The next problem says that a bar magnet, when placed at an angle of 30 degree to the direction of the magnetic field induction 5 into 10 to the power of it is minus 4 Tesla, experience a moment of couple 20 in 25 into the power of, I hope it's 4 again, 4 Newton meter. If the length of the magnet is 5 centimeter, its pole strength is the question here. Correct? So in this case, I need to calculate we have given the value of torque as well, the torque Newton meter, and the magnetic field is also the same formula, that is what, m into b into sine theta. Let me use this one now. The torque is given as 25 into 10 to the power of minus 6. This must be a minus 6 here. That must be equal to the magnetic moment. The magnetic moment is nothing but pole strength into length of the magnet into b into sine theta, like this, correct? So this is equal to the pole strength we need to calculate, and the length, the distance is how much here? The length is 5 centimeter. 5 into 10 to the power of minus 2. The magnetic field induction is nothing but 5 into 10 to the power of minus 2 here. It is minus 2. 5 into 10 to the power of minus 2 Tesla. Okay, 5 centimeter as well as 5 into 10 to the power minus 2 Tesla into sine theta. So now theta is given to be how much? 30 degree. This is 30 degree. Let me use here. Okay, so therefore I will get magnetic pole strength M must be equal to 2 into 10 to the power of minus 2 ampere meter. So option A is the right answer for this question. Okay. Next problem says that at a place where the Earth's horizontal component of the magnetic field is 0.36 into 10 to the power of minus 4 Weber per meter square, if the angle of dip is given as 60 degree, then the vertical component of the magnetic field at this place in Weber per meter will be approximately, correct? As you know that horizontal component of the Earth's magnetic field BH equal to B times cos pi, and vertical component must be equal to B into sine pi. Clear? So that's the reason why BV divided by BH must be equal to something but tan pi here. So therefore I can say that we can say that BV equal to BH tan pi. BH tan pi. So therefore BH is nothing but 0.623 into 10 to the power of minus 4 Weber per meter square. Weber per meter square. Okay, so 0.623 is option D is the right answer for this question. Just I have substitute the value for BH as well as tan pi as 60 degree here. Okay, so the next problem says that the angle of dip at the place is 60 degree. At this place, the total intensity of the Earth's magnetic field is 0.64 units. The horizontal intensity of the Earth's magnetic field at this place will be. So as we know that the BH equal to horizontal component BH equal to B times cos pi. So we can say the pi is nothing but 60 degree. This is 0.64 into cos pi, cos 60 degree. That is cos 60 is 1 by 2 here. So that's the reason why it is 0.32 units. 0.32 units. Okay, so option, which option is correct here? So option D is the right answer for this particular question. Okay, so next problem says that when a piece of a ferromagnetic substance is put in a uniform magnetic field, the flux density inside it is 4 times the flux density away from the piece. The magnetic permeability of the material. So you know that magnetic permeability mu r equal to B divided by B naught. So this is what the magnetic field intensity inside, and it is the outside here, okay, or the away from it. So that's the reason why the inside it is 4 times, right? Inside it is 4 times divided by it is 4 times B out. This is B out as usual. So B out cancels. We'll have to with what? Mu r equal to 4. So that's the reason why option D is the right answer for this particular question. So anyhow, thank you very much for watching this video. Please do subscribe to our channel and share this channel as the contents with your friends as much as possible. If you have any doubts, just make a comment on the comment box so that I can help you with. Wish you all the best for examinations. Good luck.